showing that one is phosphotrioxychloride, trichloride, in the presence of pyridine. It's a dehydration reaction. And I have sulfuric acid on the same compound, also a dehydration reaction. Both are dehydration reactions, as you see, because they form an alkene after loss of water. The question here is that between these two reagents, the top one, the phosphoxytrichloride in presence of pyridine, gives only one single product, pure that alkene. But in the presence of sulfuric acid, you get compound B, compound C, compound D. 3 different reaction mixture in the products. So the question is, show mechanistically, by showing a mechanism, why that is true. Why is that the reason? So the first thing you have to see is when you have diverse compounds as a product B, C, D in the dehydration reaction, what comes to mind is there is rearrangement. Obviously, there is a carbocation or a metal shift or a hydride shift, so that you have different possibilities for the product. So that's the reason. So between this reagent and that reagent, even though both do dehydration, the phosphoxytrichloride doesn't lead rearrangement. So it's purely a one mechanism, purely an SN2 reaction that happens, or an E2 reaction that happens in the presence of pyridine. So purely this is an E2 mechanism without rearrangement. No rearrangement for this. So if I were to draw a mechanism for this one, I will write it very squeezing here what I see. You have this, O, the phosphorus would coordinate here because this would attack that phosphorus. 1 chlorine leaves. So you have Cl, and still this is true. The Cl minus would be floating around here. So that's what we have, and you have pyridine. So now you are forming this intermediate after the oxygen attacking the phosphorus oxytrichloride. Then now